Abacus is a mathematical instrument used to perform addition, subtraction, multiplication, division, and even can calculate square root and cubic root. It is most commonly made from wood, and components consist of beads, rods, and frames. Inside the frame, there are certain vertical rows corresponding to place value. The classical abacus contains a lower deck with 5 beads on each rod, and upper deck with 2 beads. Each bead represents a number. For example, on the abacus image showing on the screen, the rows on the very right represent 1's place value. Therefore, each bead on the lower deck will worth 1, and each bead on the top deck will worth 5. As we move to the next row, the place value will become tens. Therefore, each bead on the lower deck will worth 10, and each bead on the upper deck will worth 50.
How has the abacus developed over time? The abacus has evidence of being used back as far back as ancient Rome. These abacuses were very small, and due to very few being found, it is thought that they were not very widely used. Early abacuses were often simple counting boards. People would move stones and pebbles to help with counting and mathematical operations. As the abacus moved to different countries, each country created their own unique version of the abacus. China had the swan pan, which was divided into 2 decks. Japan had the saraban, which was not commonly used until the 17th century, and it is still in use today. People who are skilled at using the saraban can often calculate faster than someone using a modern calculator. Done.
According to Wang et al., the abacus-based mental calculation training can alter the functioning of the brain and visual spatial working memory tasks to enhance the relationship between arithmetic ability and working memory. This enhancement can allow for faster recollection of arithmetic practices such as addition, subtraction, division, and multiplication. In this study, it was found that children who learned abacus-based mental calculation methods became able to visualize the abacus and perform arithmetic practices without needing the physical abacus. Through the conduction of this study, it was found that children involved in long-term abacus-based mental calculation training performed better in both arithmetic and visual spatial working memory tasks than those who were not involved. The study highlights that long-term abacus-based mental calculation training improves the arithmetic ability and enhances visual spatial working memory performance in children, meaning that it is possible that a combination of abacus-based mental calculation and classical working memory training programs is better suited to the environment of both arithmetic and working memory performance than the training that just targets one of them.
There are many types of abacus. Today we are using this one to demonstrate how the abacus works, as they are readily available in many toy stores. The place value increases from the bottom to the top as demonstrated on the slide.
Okay, we can see on our slide how each bead correlates to the place value system. So now I'm going to show you how to do a simple sum to demonstrate how the abacus works. We will add 3 and 9 together. So first of all, we'll start with our ones units, and we will count across 9 beads. 1, 2, 3, 4, 5, 6, 7, 8, 9. And now we'll add our 3. 1. We can't go any further, so we need to swap our ones units for a 10. So we've moved our 10 across, and now we'll continue. We've already counted 1, so we'll start from 2, 3. Now we'll add them all together. So we've got a 10 and 2 ones, which equals 12. And that is the answer to our sum.
And now I'm just going to get everybody to use this link on the slide. It's a link to an online abacus, and you guys can follow along with another calculation. All right, so here we have our online abacus. So if you've got this up on your computer, you can just follow along. So as you can see, all you have to do is hold down on the mouse and you can move the little pieces across. Now on this online abacus, we're just going to do a calculation a little bit harder than the one before. So we're going to do 63 plus 36. So first of all, we want to count 1, 2, 3, 4, 5, 6 in the tens column for 60. And then 1, 2, 3 in the ones. That's our 63. Now we're going to come back over to the tens and go 1, 2, 3 for the 30. And then in the ones, 1, 2, 3, 4, 5, 6. And that makes our 36. And now we can actually figure out our answer. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 in the tens, which is 90. And then 1, 2, 3, 4, 5, 6, 7, 8, 9 in the ones, so 9. So that means altogether we have 99. Now we can actually move on to more complicated calculations such as multiplication, but for now we'll just leave it there.